So thank you, everyone. If you want to grab seats here a bit, thank you for joining us on this brisk Thursday afternoon for the first and our final two lunchtime expedition presentations of 2019. Just a couple quick announcements. This one's going to go for myself included. Please silence or turn off your cell phones so that they don't go off during our presentation. Support for these programs has been made possible by the Nancy-Caroll Draper Charitable Foundation as well as Sage Creek Ranch. I mention this each time, but the quality and the caliber of the speakers that we're able to bring out time after time has only been made possible through the generous support of our sponsors, and we hope to continue delivering this high-quality content for you guys far into the future. So these lectures are being recorded and uploaded to YouTube. If you go to youtube.com, you type in Draper Natural History Museum, it'll bring you to a list of all of our previous presentations for 2019 as well as for 2018. So if you've missed any of the previous ones, you can find them there. If you miss any of the future ones, you can find them there. If you'd like to be added to our email distribution list, just please come find me after the presentation, flag me down, I'll come by with the clipboard, we will get your email, and we'll also get you on the list. That'll include links to the emails that go out, include the presentations that are coming up, as well as links to previous talks that have recently happened. Our last talk is on December 5th, and will feature Tony Mong from the Wyoming Game and Fish Department. We're going to break for the holidays and then resume our 2020 lecture series on February 6th. So we have an exciting list of speakers in the works, and to kick that off will be Nathan Dorr, the newest addition to the Draper Natural History Museum, who's also going to come up and say a couple words.
Thank you so much, Corey. I wanted to take this opportunity. As you now know, you'll get a chance to learn a little bit more about me come February, but I wanted to take the opportunity to acknowledge the work that Corey has done and thank him for putting together some phenomenal series, and he has a great list coming up for 2020, so I certainly look forward to that. A big thanks to all of you for your ongoing support in attending, taking time out of your days to attend these programs and support the programs here at the center in general. And of course, to reiterate, a big thanks to our sponsors, Sage Creek Ranch and the Nancy-Caroll Draper Foundation, for their ongoing support of these programs. And lastly, like you, I'm excited through these programs to look forward to going beyond the walls of the Draper and the center as a whole as we learn about and experience and explore the greater Yellowstone. So thank you so much. I look forward to talking a little bit more about myself and the future with the Draper in February. So thank you, Corey.
And so today, we're going to hear from Mr. Jarren Kuipers, who has worked extensively with both public and private landowners. Jarren is a wildlife biologist, owner, and operator of Land Steward Services LLC, operating out of Cody and Missoula. Jarren has a long history of working with Wyoming's wildlife and stakeholders. Prior to his current role, he was a conservation easement specialist with the Wyoming Stock Growers Land Trust, Tallgrass prairie biologist with the Northern Prairies Land Trust, and also a University of Wyoming research associate studying sage-grouse in Lander, Kemmerer, Pinedale, and Jackson Hole. Today, Jarren is going to discuss some of his work with the Nature Conservancy and how removal of a non-native species has impacted small mammal communities in Wyoming. Please give Jarren a warm welcome.
All right, well, thank you, Corey, and thank you all for coming. Let's see, make sure I can get this first. That was the wrong one. There we go. Okay, well, perfect. Well, again, thank you for coming. It's great to see so many people here. I know I've really appreciated this series from time to time, coming to see these presentations, and it's a little intimidating because I know how good they are, so I really appreciated that. And also, I wanted to recognize TNC. They contracted with me to do a large portion of this study, but they guided every aspect of this, and they fundraised for it and got the collaborators together. And so this is a TNC project that I was just fortunate enough to tag along on, sort of. So just wanted to recognize them, and I'll recognize the other funders at the end as well, and other contributors. Okay. So first off, I wanted to just draw attention to this photo. I think I will use this mic. I'll use this one. Okay, so this photo is actually on one of our study sites, and just as I start this up, I wanted you just to look at this photo and see the differences between one side of the river and the other. Oh, perfect. Thanks, Corey. All right. And you can see, obviously, on the right-hand side of the river, you see lots and lots of Russian olive, and that's kind of the ultimate end point, I guess, for Russian olive taking over an area. And then on the left-hand side, you see a diverse mix of shrubs and grasses and forbs and trees. And these are kind of the two, this is kind of what we're looking at with this study. What are the differences here, and what do we gain and what do we lose? And so that's just a little bit of a closer view just from a small mammal perspective, I guess, the differences between these two sites. And if you're curious, this larger photo is actually taken just below Willwood Dam. So one of the interesting things I think about this talk compared to maybe some others that you've witnessed here is that it's all local research. You're going to recognize a lot of these sites. They're just right in our backyard. Hopefully this is a topic that is important to you, or at least informs how you see the landscape to some degree because it is local. All right. So what does this mean for small mammals, those two sides of the river? And I guess also, why do we care? And so small mammals make a pretty good research topic because they respond so quickly to habitat change. They reproduce really fast. They don't reproduce as fast as rabbits. They're even faster than that. They're just, they respond right now. The babies are having babies, within the same season. And so they make great research topics for that very reason. You can cause some kind of habitat change, and the response is really quick. There's also usually a variety of them out on the landscape, which gives you some opportunity to look at diversity. And then lastly, they don't range terribly far. They might have a home range of 1 acre or 2 acres or something like that. And so you can impact those habitats right in a small area and see a response from these guys. Whereas if you were studying a larger mammal like a coyote or a fox or a raccoon, they're obviously covering large distances, and so you can't impact those habitats and know for sure whether that was what caused the increase or decrease in the population. Another reason is because small mammals are at the bottom of the food chain, and they're kind of that base for so many different critters out there on the landscape. Anything that calls itself a predator usually uses them to some extent, and that can be reptiles, it can be birds, obviously it's mammals, and so there's just a whole slew of animals that depend on them, and it just cascades up the trophic system. So, and oddly enough, even some birds like blue herons I've seen eat a lot of these small rodents right in the riparian zones, and you'd think of them eating fish, but a lot of them exist right on the water's edge. Another one you might not think of is trout, and this is a lake trout, and it was not on the Shoshone River, but that's a large vole that came out of that fish. And so that's not terribly uncommon, and certainly some of our brown trout are eating meadow voles and long-tailed voles that are swimming along the shoreline. And actually, if you walk down by Belfry and you're walking through the grass and you see a small rodent swim out into the water 10 feet and come right back in, it was probably a vole. It might look like a baby muskrat or something like that, but actually those voles are quite semi-aquatic, and so they're vulnerable to fish. This was the predators will at times try to pry them out of the traps, and they're usually not successful. That was not a brown trout. All right, so just to talk a little bit about Russian olive. Most of you know what a Russian olive is, I imagine, and what it looks like. We have lots of them around. They're originally from the temperate Western Asia area, and I had to look that up to see what that actually included. But it includes a huge swath of country, so it's got a very wide range globally. And in those places, it acts kind of like part of the plant community, from what I understand. It isn't running rampant or anything like that. It was introduced in the U.S. around 1900, 1910, And it was right away used as a horticultural plant. It wasn't brought in by accident. It was brought in intentionally and spread around intentionally. And originally it probably wasn't meant for riparian zones. They used it for hedgerows, ornamental reasons, just around houses as windbreaks, things like that. And it was spread around by individuals, private and government, and you name it. And so that's kind of how it made its way everywhere really fast. It's a generalist for the most part, and it's not super competitive in a lot of situations. If you plant it in the uplands, it might grow, but it's not going to necessarily take over. But if it gets in the riparian zone, those kind of disturbed areas, it really takes off. And for a while, it acts like part of the plant community, and it may even be additive. But then eventually, it takes over and crowds out the native species, and that's really the rub. That's where the trouble comes in. And as land managers, as people, we have to decide, if we want that to happen or not, and and understand what the consequences are to those actions. Okay, so it's relatively easy to understand what you're gaining with an introduced plant, but it's hard to understand what you're losing. And so this is, with Russian olive, it becomes eventually an either-or situation, either all Russian olive or you keep your native plant community. And these are just some of the natives that you lose. We obviously have a lot of willows in our riparian zones, diamond willow, sandbar willow, Beebs willow, and then peachleaf willow is our tall tree willow that we have. We have silver buffaloberry, which looks kind of similar to Russian olive, and also other fruiting shrubs like chokecherries in these zones. Wild licorice is a common species in these areas. It's more of a weedy species, and you may not like it. It has a little cocklebur kind of seed that gets stuck on stuff, but it is a native species. And there are lots of other forbs out there that are important for, producing insects and for pollinators and that sort of thing. And then also lots of grasses. So Canada wild rye would be one, but there's many others. I should mention these riparian zones that are not filled with Russian olives yet. It's not as though they're pristine necessarily. There are introduced species in them. There's lots of hay meadow species, timothy, smooth brome. Reed canary grass is one we probably prefer we didn't have. But we do have that one in abundance too. And so they're not pristine, but they are diverse. And then lastly, occasionally some of our riparian zones around here have narrow-leaf cottonwood. This is not from the Shoshone because there's an aspen in there too. It's not a basin photo. But so that's kind of the environment that we're dealing with here along the Shoshone River. And now to just kind of introduce you to some of the study subjects that we're working with. That's a little harvest mouse in there, by the way. The main species that we caught were deer mice. They're super common. They're found just about everywhere. They're probably the species that tries to sneak into your house if you live on the edge of town whenever we get weather like we're having right now. And so they get around, and they're just kind of found in all types of habitats, but they're very successful in the riparian corridors and native areas. And that's just another view. They look kind of like a hamster to me, with a long tail, usually furry tail, and they've got a white belly. Next one was western harvest mouse. We caught quite a few of them too, a little bit more selectively, but there were good numbers of harvest mice. They're unique in that they escape really easily when you're trying to trap them because they're very good jumpers. And then they also, that tail that they have is pretty long, and they use it in a prehensile fashion. And so you'll see sometimes a photo of a mouse climbing up a grass stalk with its tail wrapped around it. Often that's a harvest mouse. They use that as a fifth limb kind of, and they get up into most likely up into Russian olive trees, but also up into just grass stems and stuff like that to gather seeds. And those are just another one. They look a little bit more like our common house mouse to some degree. Meadow voles are very common along our riparian corridors. They're just chunky little guys that have short tails, and they swim really good. And they always the behavior was kind of interesting with them. They motor around all the time. They don't move fast, but they're always going. There's a couple more views. And then longtail vole is the last one. We caught quite a few of them, but they were pretty selective to specific areas as well. They're very similar. Long tail kind of sets them apart. And they were interesting in that behavior-wise, they just did not like to be handled. They just pee all over the place, and it was just a total mess and fight. And then you'd set them down, and then they just sit there and look at you for a few minutes. You know, they just didn't. Then they were totally good. But other potential species we thought we might find included Montane Voles, and we probably had some in there. They're difficult to tell apart from meadow voles, and where you actually, from what I understand, have to look at the backside of their incisors, and so we didn't look that closely. We had a lot of traps, and so they were actually lumped in. The other ones we did not detect, other than western jumping mouse, and we just had one capture, and that was the first year of the study before I started. We didn't have any shrews, but shrews are often insectivores, and so they wouldn't go to our bait probably quite as easily. And then also they're very light, so that it's possible they were not captured. Okay, so our objectives of this study, as it was set up in 2014, was to determine if Russian olive removal was effective at increasing the small mammal population, and then also to look at species richness, to see if we had any differences in species richness between cleared and not cleared Russian olive areas. The methods we used included 4 sites, 2 control sites that did not have Russian olives removed and 2 that had Russian olives removed. We did anywhere between 86 and 100 traps per site, and we checked those for 4 straight nights every year that we did the study, and that was 4 years of actual trapping. We measured body length, tail length, foot length, and also weights, and those are kind of standard for small mammal studies, and also for determining species to some degree. And then distance to water was something we were also interested in. Okay, so here are some areas that you're probably going to be familiar with. That Corbett site, that was our first control site where we did not clear trees, and we just sampled it. That is right below Corbett Dam, so that's pretty familiar, just right outside of town. And we did get access across private ground to do that site, and we really appreciated the private support that we did have to access 2 of our sites. We had the private was actually another one of those sites, as you might guess. That was actually BOR land, but we had to cross private to get to it. And then the 2 treatment sites that we had were both on the Willwood public area that are found just below Willwood Dam that extends for several miles. Willwood West is right below the spillway, and Willwood East is on the far eastern side of that public area. We'll look at those a little bit closer. Okay, so this is Corbett, and I'll try to explain this just a little bit here. Okay, this red line right here, that's our actual trap line that we followed. And then the green here was actually mapped out Russian olive of 50% canopy cover or greater, and that was just visual. This is a 2013 photo, and so this was prior to any treatments that took place, although this is a control, so we didn't actually clear trees here. And this is a 74-foot buffer that we put on there, and 74 feet is just the diameter of a 1-acre circle, which is the approximate size of a home range for many of the species we were tracking. So we tried to make that biological somewhere. This is the Corbett site, not my best photo, but in any case, there are lots of shrubs along the shoreline. It was really a mix of Russian olive and willows, and some cottonwoods in there, and a variety of shrubs. So it was a little bit different, and it'll come up in the results as well. It's kind of an in-between site where it wasn't completely dominated by Russian olive, but it was definitely there. The second one was our private site. And this was, again, right above Willwood Dam, right below Buck Creek boat put in, kind of your last stop before you go over the dam. So gives you kind of an idea, just right in that area. And the same thing here. You can notice with these control sites, our trap line, and especially here, is very wiggly. And part of that is because we just simply could not penetrate that Russian olive stand. This is just directly across the river, and so it gives you a little bit of an idea. That is actually less dense and not as old as the stand I was in, but it looks like this in the understory. And so you can imagine, trying to go in a straight line through that is pretty challenging. Our site right below Willwood Dam, Willwood West, you can see this was kind of patchy as far as what it had for Russian olive. It'd be right below the dam. And then it looked like this. That's what the Russian olives cut out. The willows came back in, and there's a little bit of herbaceous as well, some roses and a few other things. And this is the willows as well. Pretty thick willows in places that came back in. And then the last one here is on the far eastern side of that public area. And gives you some of an idea as well as far as what it had for density of Russian olive. And that's a photo of the area. There are some Russian olives you can see actually popping up. This was the last year of the study, and there were some that I don't think they were treated during the extent of the study. There wasn't that much resprouting, surprisingly. That's always a question. But these are obviously, they came off of old stumps that got cut. Maybe a stump got missed or something like that. But in general, these areas stayed pretty clean of Russian olive that we treated. And this is another view of just a little side channel from the river running right alongside of our trap line. I just wanted to show this just to show that our sites were fairly similar to start. You can see everything between 61% of Russian olive canopy cover, 50% or greater, and down to 46. So it appeared pretty similar. This was just a really rough look at Russian olive density. Unfortunately, we didn't have pre-data to look at, so we had to kind of go back through historical imagery. I'll just run you through a little bit of the process here. What we would do is we'd set all these traps out. We'd have 400 traps to check that day. Usually it was just one person. Usually it was me, but this day I had a recorder and a camera person who was my wife, and she occasionally came along. And so what we would do is we'd put a little ball of batting, polyester batting in these traps, something that keeps them from, allows them to kind of create a nest in there over the night, so that we didn't, this was a catch and release study, so it wasn't a snap trap study. And so we could release them unharmed. And then what we do is transfer everything into a plastic bag, transfer the mouse over into a mouse or shrew or vole or whatever we ended up with in another plastic bag that was clean, do our measurements, do our weights. That's a harvest mouse. And then you'd subtract the weight off of there to get the weight of the mouse or shrew or vole. And then this is the first of our results. I'm only showing 3 sites here, and we had 4. And the reason for that being is, unfortunately, we didn't have pre-data on one of those sites. And I wasn't involved in 2014, but I wanted to just show where those 3 sites started off in 2014, just to give you some idea. And just keep that in mind, that one of our treatment sites was treated at the exact same time as these other sites in the exact same area or region. It just didn't have pre-data. And so in 2014, these are capture rates, so 10 to 15%, or 7 to 15% capture rate on traps in these areas. And then right after the treatment in 2014, it shot right up in our treatment site. And our control site stayed about the same through 2018. And then this last year, things went a little bit haywire. So it was pretty easy to explain up to that point, and then it changed a little bit, but we still had much higher capture rates when looking at all 4 sites combined. Okay, so I'll try not to focus too much on these graphs. I'm sure you guys love graphs, as much as I do. But in any case, if you look at those blue lines, that's all years combined for after the treatments took place. And you can see these sites, the two controls are the ones on the left-hand side, and they had much lower capture rates than the ones where we actually removed the Russian olive. So kind of fit what we thought would happen. And then over the years, it kind of stayed the same, and then this last year, everything shot up. We just had a really good year for mice, I guess, among other things, I think. But here is the same thing. It's just the controls together and the treatments together. And so you can see this removal of Russian olives had a pretty profound impact on small mammal populations. It was a significant impact all the years of the study. And then obviously in this last year, it really changed. We finished trapping in early October, and we just got the data entered just prior to this. And so I was able to put it in here. But I think the reason why this year was so good was in those dense Russian olive areas, and that's again what this is, we actually had some vegetation growing in there. Whereas in other years, it's so dense in those Russian olive stands that there's nothing growing in there. And so I think that was just enough to spur some of those populations on, particularly for one species. So these are our 4 species that I mentioned previously: deer mice, harvest mice, long-tailed voles, and meadow voles. And of the 4, 3 of them were much more common proportionally on the treatment sites, on the control sites, or treatments, excuse me, and then 1 on the control sites, and that was harvest mice. And so harvest mice, I mentioned, they're slightly arboreal. And there was something about those Russian olive areas where they were able to capitalize on probably a little bit extra moisture and cool conditions this year. It was just enough to make their populations boom. And so we actually had more harvest mice on our Russian olive areas than we did in some of the other, in the treatment areas, which is kind of interesting. And that was just really this 1 year. But it was enough to change it overall for the study. Otherwise, otherwise we had many more captures in our treatment areas. We did look at diversity and at our species richness. And actually, we didn't see any difference between our treatment sites, where we cleared the Russian olives, and our control sites where we did not. And part of that is because we're not dealing with that many species. We were only capturing 4 species, really. And some of these sites had real high deer mice populations, and that kind of washes out your species richness to some degree. And so overall, we did not find any significance for species richness between the 2 different types of areas. This I put on here just to prove that we did statistics. And we did find significance between our treatment sites. Years were also different, and also we had significant differences between our sites. And so the question then becomes, which side of the river do we want? Which side of the river is going to give the most benefit for local wildlife and for people? Obviously, that's a decision for everybody personally, and I can't make that decision for anybody. There are positive qualities to Russian olives. They provide a lot of the reason and the resistance to clearing Russian olives is because they provide a type of habitat that's kind of rare in the basin. We don't have that many trees, and overall, it's just a difficult sell to tell people to kill trees in places where few trees will grow. At the same time, Russian olive don't play very well with others, and so having a few around is not a big deal, but once you allow them to crowd everything else out, you've really lost something substantial, and particularly your productivity in an area that really has the most productivity in the whole landscape, which is that riparian corridor, and that's for wildlife, that's for livestock production, you name it. And so it's really, I guess, something to think about, whether you want to see what's on the right-hand side of the river or whether you want to see what's on the left-hand side of the river. There were, like any study, there are lots of opportunities for future research and potential improvements in the future if it continues. One is just getting more vegetation data. We didn't sample vegetation pre or post for this, other than going retroactively back and looking at tree densities in these areas using aerial imagery. And it would be really interesting to know what is driving those changes in small mammal population. We know a treatment happened, and we know what we got for trapping results, but we really don't know the ecological function behind what's causing that. We assume it's because the native vegetation came back in. We can visually see that it looks pretty good, that the native vegetation appears to have recovered and came back into those places. But we can't definitively say that because we don't have data. And so that would be really interesting to have, to know what the shrubs and the grasses and the forbs are doing on both sides, the treatments and the controls. It would be nice to be consistent distance from the water. We were trying to keep everything really close to the shoreline, and because Russian olive is so thick, I mean, it's just incredible. It's just impossible to penetrate a lot of it. And so what we ended up doing is going around Russian olives at times just to set our lines, and that probably put those traps in more productive habitats, quite honestly. It put them on edge habitats where we see typically more small mammals. And so I have a feeling that the results might have been even more profound if we could have actually penetrated and put those traps in the middle of these dense Russian olive patches. And so that's something to consider, is maybe just trap setting from the water instead, which would have other challenges, but one way to get around it. Also, we had all these piles on our treatments. That's a lot of Russian olives to cut, and they have to go somewhere. And so they put them on these big piles, and they were not burned, but what that means is we had a different kind of habitat now that was not present on our control sites. And so that was kind of the something to think about, is burning those piles just to make the study a little bit cleaner and getting rid of that variable. And then also, the site that was most intriguing to me with this study was that private control, that really dense Russian olive area. It seemed like a desert underneath the thing. There was just almost no vegetation. And it'd be interesting to look at those sites and to see how they recover if you cleared them out. If you cleaned them off, would they come back into native species? Would it just be solid Canada thistle or something like that? And so you really, I guess that would be a kind of an interesting thing. And also I think those areas are the most profound because, you know, we can look at aerial imagery through time and we know that these thin Russian olive stands that we're seeing are moving in that direction if there's no action taken. And so it'd be nice to know what happens if we let them all go that far. So with that, I would just like to recognize the many contributors to the study. Again, I mentioned TNC guided this study from start to finish, and they contracted with me and allowed me to do this. And then I also used traps from the Wyoming Game and Fish, all 4 years, 400 little traps, which was fantastic. It would have been really expensive to do it any other way. And so we had that was a huge help from them. And then we had a bunch of, I assume, funding partners. I don't know everybody's contribution, but a bunch of people locally chipped in to make this possible. So I just want to thank them and thank you for coming.